everybody, today I'll be presenting on behalf of my group members. Those are Anika Shahnaz, Kanav Bhatia and myself Rashita Gupta. I'm here to present the pandas file. How does that work, and how I'll be presenting, and how the different libraries have been moving. So I'm working on the logistic regression. So here's about logistic regression and how the file works in this. So first we have to import the file that was given, adult income regression. So this will help us give the data frame. So the first library that is used is pandas as PD, which will help us the entire data table into a NumPy matrix array. The second library that we have used is import label encoder, which can be used to normalize labels. It can also be used to to transform non-numerical labels to the numerical labels. The third library is chain underscore test underscore split, which means splitting data errors into two subsets for training data and for testing data. With this, we don't have to divide the dataset manually. We can just do it on a basic way. So for the import logistic regression that we have used is relationship between the dependent variables and one or more independent variables by estimating the probabilities. We can estimate the probabilities. And then we have used the confusion metrics. So this helps us to assess the performance of a clarification model. So which means that the number of correct and incorrect predictions are summarized with count values and broken down by each class, which can be broken easily. So our first step is we have to import the data. The first step that we have to import the data, that is pandas PD from the PD. So df equal to pd dot, and we are importing the data, and that will display the whole data set into our system as shown here. So moving forward, generate a new data frame including age, education, num, sex, hours per. Okay, so we have to generate a new data set. So if we are using new underscore df, and we are generating a data frame with the column age, education, sex, hours, native country and income, and we are just presenting like this. So it will give us the whole data set like this. Now third is investigate the missing data. Okay, so the third step is we have to investigate the missing data, and how we do is missing, we are taking the data set equal to new data set dot is null dot values and dot any missing values. So if we represent this missing underscore df, and it will give the false value if we run. Convert the non-numeric features to numeric. So now we are converting the non-numeric features to numeric. So to do that, we have imported the file here, which was logistic regression, which means, right? So for logistic regression, it's like not the logistic regression, sorry. Sorry. So it's the label encoder that we have used. So label encoders help us to generate the non-numeric values features to numeric. So that helps us to convert the file. So if we are doing the LE equal to label encoder, we are defining new dataset sex, native income, and then we are transforming to the numeric variable. So it will look like this. If we x is going to drop income axis, and then income we are doing. Okay, so if what we are doing in this, we are excluding income, we are taking all the columns, and for the x-axis and for the y-axis we are taking just the income thing, and that is for testing and training purpose. So for testing, this is the second step we will be doing. So split the data into the train and test. So we are splitting the data into train and test, and for splitting we have used the library train underscore test underscore split. So we are taking x train, x test, y train, y test, and then the thing, and then we are testing like 30% and then training is 70%, and then we are taking the random state equal to 42. This will help us run more easily. So this will